Okay, ready?
Okay.
3, 2.
Oh, wait a minute.
3, 2, 1.
From KARE11 News, it's Simply Science, Electric Weather. Now, here are Ken Barlow and Belinda Jensen.
Hello, welcome to Simply Science. I'm Belinda Jensen.
And I'm Ken Barlow. To broadcast the weather every day from the studio here at KARE11, we rely on a maze of lights and wires carrying billions of bits of information around.
Well, like most people, we're very amazed by all this electronic gadgetry, but sometimes, don't you wonder, how does it all work?
Well, in this edition of Simply Science, we are going to let you in on a few of our secrets.
And we're going to let you know a little bit about the waves of energy that brings our picture and sound to you. So stay tuned for electric weather.
Our show begins at the Pavek Museum of Broadcasting in St. Louis Park, where young people discover the sparkling delights of electronic communication.
From a spark gap transmitter built the year the Titanic went down, to a radio with enough chrome to build a bumper, the museum's antiques tell of the days when radio ruled the airwaves.
From the early days of television to the early days of my career, to radar systems that see raindrops, we cover the tube.
Finally, we go behind the scenes here at KARE11 to show you the magic of Chromakey and digital video effects.
Hey, Belle, have you ever had a close call with lightning?
No, I haven't.
I have.
Tell me about it.
I will. It was about 10 years ago. I was working on a farm, and it looked like the thunderstorm had passed, but I suddenly felt the hair on my arms and my head stand up.
In the field?
Yeah, and a telltale sign of lightning strike, because
Right.
we study that, and we know that. I dove into the truck, and about 5 seconds later, 25 feet away, pow.
Lightning flashes somewhere on Earth more than 100 times each second. That's 3 billion times every year. From earliest times, people have revered the power in lightning, and with good reason. More people die from lightning strikes than almost any other severe weather event.
Those are chunks of amber. Have you heard of amber before?
No.
Students come to the Pavek Museum of Broadcasting to study the history of radio and television, electronic communication. A typical field trip starts with one of the first materials found to have electric properties, fossilized tree sap.
Electron, that's where the word electricity came from. Well, it's the Greek word for amber. 600 years ago, someone was rubbing a piece of amber and it started to act like a magnet, drawing things towards it, repelling things away from it, and they thought that the amber was alive. So anything that displayed those characteristics of magnetism or static, they started to call electricity after the Greek word electron. Here you go.
An electrical charge was conducted around the circle hand to hand. Today, we know a charge is made of free electrons, rushing to get discharged.
How they get free, you ask? Well, atoms are the simplest building blocks of matter. The nucleus has a positive charge, while electrons, which have a negative charge, circle the nucleus. When a force, like friction, say when you're rubbing your gloves together in a dry winter night, or winding that static generator over at the Pavek Museum, when a force excites the atom, some of the electrons get free. Collect them, and you've got lightning in a jar.
I'm scared.
People seem to enjoy the shock, so folks were soon using jolts of this electrical fluid in therapy.
The first devices that actually produced electricity were generators like this one, and then later batteries came along. You ever seen batteries like those?
During the 18th century, scientists like Benjamin Franklin were trying to find out how electrical fluid was related to lightning. Ben brought heaven's fire to the ground in the summer of 1752. He attached a lightning rod to a silk kite. Free electrons in the clouds jumped to the rod and flowed down a silk string, collecting on a key. When Ben touched the key, electrons jumped in a spark to the ground through him. That day, Franklin unlocked the door on a force our eyes can't see: electricity. Almost 100 years later, in 1844, scientists figured out how to use this invisible force to send a message down a wire.
The telegraph was the first form of electronic communication. And the telegraph used the Morse code. Different combinations of dots and dashes make all the letters of the alphabet.
When power flows out of a battery or a generator, the sending switch turns the current flow off and on. The receiver receives the current flow and clicks out the sequence as transmitted.
For example, 3 dots make the letter S. 3 dashes, which are just slow dots, 3 dashes make an O, and 3 more dots. What do we say?
That means help.
SOS, right.
Save our ship.
Well, it means help. It's kind of an early form of 911.
Save our ship.
But until somebody figured out how to send electrical messages through the air, ships at sea were really at sea. The year is 1912.
We're down in the wireless room. We've just struck an iceberg. What should we do?
Call for help.
Right, we're going to send out that SOS and hope someone hears us. That was radio in 1912. No voices or music, just dots and dashes.
That's kind of cool.
Don't touch that wireless receiver. When Simply Science returns, we're going deeper into the waves of sound.
Hey Ken, you're talking radio telegraphy.
Wave on, Belle, the sweet sound of radio.
Welcome back to Simply Science. Here in the audio booth where we record the narration for weather stories, it's amazing to realize that less than 100 years ago, there was no broadcasting. At the time, scientists were still discovering the magic of wireless communication.
We're playing with a Tesla coil and we're lighting up this light bulb. Tesla at the time was thinking that he could transmit power without any wires, and you can see how that...
At the Pavek Museum, visitors follow the trail of technology blazed by scientists to explore the invisible world of energy, the electromagnetic energy we see as light and hear as sound. You can try your hand at Morse code, or pick up an antique telephone, or wind a replica of Edison's first voice recorder, the phonograph, or take a turn on the Amberola.
So it doesn't reproduce quite as well.
All sounds from the lowest to the highest have a frequency, the number of times per second the wave of sound energy vibrates. We call it a hertz, for the German physicist who first detected radio waves in 1888.
The lowest note on a piano is a bit under 30 hertz. A good low frequency, for example, is 60 hertz. That's the frequency of the power line. When you hear something that you plug in the wall humming, that's 60 hertz.
As scientists discovered more about the sun's radiation, they made a scale known as the electromagnetic spectrum that organized these waves of energy by their frequencies of vibration. At the slow end, sound waves the ear can hear. Radio waves vibrate much faster, up to 300 million times per second. Next fastest, microwaves, 10 billion cycles per second. Human skin senses infrared energy at 10 trillion cycles per second. The human eye is tuned to a frequency of 500 trillion cycles per second. Faster yet are ultraviolet rays, then X-rays, and finally gamma rays at 1 billion trillion vibrations per second.
Oh, there's some great music that was played on theremins. And even some contemporary good vibrations with the Beach Boys. It goes da 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 da.
Yeah, that's
so
right.
Brian Wilson of the Beach Boys would be a theremin player.
The exhibits at the Pavek Museum tell the stories of scientists like Marconi and Fessenden, inventors like DeForest and Armstrong. Each of them, in his turn, found new ways to use the radio frequencies of the electromagnetic spectrum to communicate better.
We've got one of the largest collections of antique radios, televisions, and broadcast equipment in the country. It's a 1941 E.H. Scott Philharmonic, 33 tubes, AM/FM. It was a Rolls-Royce of radio in its day. It was $439 new.
The museum's collection even includes an early example of talk radio.
And we've managed to leverage those collections into learning experience for about 4,000 students a year. Are you guys ready? Yep. Okay, watch your boss. Who's your boss?
Good morning, ladies and gentlemen.
Going on the air live is part of a broadcast workshop for students at the Pavek. Today, 5th graders from Normandale Hills Elementary are reading a radio script. They're working in a studio with state-of-the-art gear from the 1960s.
You guys ready? They all do have radios, and they all listen to the radio, and I think they all have an idea, some notion of broadcasting, how it exists. We just bring it all together for them with the equipment and with the action.
Ladies and gentlemen, we interrupt this program to bring you an important news bulletin.
They get an idea of how a broadcast actually originates. Besides the fact they have a lot of fun, it's a terrifically important thing because we use things like cell phones now without thinking of it. But somebody's got to know how that thing works.
Nice job, you guys.
Technical stuff doesn't just happen. Somebody has to figure it out.
Have you been on the quiz show yet?
I only met Joe Pavek, who founded this museum, once, and he was thinking of the future. He was talking about how, we got to light a fire under the kids. We got to get them interested. The need is there.
How does this thing work, Steve?
Most Saturday mornings, young people from all over the Twin Cities gather at the Pavek, from magnets to megabytes.
We built a motor, we built a buzzer, we built an amplifier, and we built a crystal radio so far.
The students studied basic electricity, the fundamentals of radio, and introductory electronics.
Logical functions.
At first, I thought that all this stuff was like, I could never understand all this stuff. And now it's like all these things make more sense. And I know how a whole bunch of things work.
This morning, they're building radios with wire loop antennas and making sure they work.
My amp worked last time.
We want to keep progressing, and if we want to stay at the forefront technically, we have to keep producing the magicians, the people who understand the insides and how things work.
A variable capacitor, and this is bigger than most of them that I've seen.
What does it do?
It's used for tuning radios.
Gary Dudovitz from the Robbinsdale Amateur Radio Club is hoping to tune in another radio enthusiast to talk with in Morse code. Gary understands and can send Morse code as fast as 20 words a minute. He's broadcasting over what amateur radio operators call a special events frequency. It's all part of the action at the Robbinsdale Radio Club's annual hobby electronics show, Midwinter Madness.
The special event station that we set up this year is a license that we were given from the FCC in honor of the fact that Robbinsdale Radio Club has been in existence for 40 years.
With thousands of other amateur radio enthusiasts, known affectionately as hams, students from the Pavek Museum radio class wander through the show, looking at new and used electronic equipment.
Well, to be a ham radio operator actually is quite fun. You can get on the air and talk, and one station I went to, I talked to Africa, Russia, and really fun.
Here's kilowatt 0, Papa X-ray. K0, Papa X-ray calling CQ.
Doug Arnson has been calling CQ, that is, calling any station, since he was a boy. His son Jacob and his friend Mike are learning how.
In the city of Asheville, North Carolina. You have a fine signal here in Minneapolis, you're 5x.
Doug's hobby became a lifelong passion when he first heard somebody from the other side of the world.
This particular instance, a guy from New Zealand came back, and I just couldn't believe what I was hearing, that this guy was calling me, and I got the map out, I looked at where he was and what city he was in, and well, I looked at the antenna and just kind of pondered, well, how can the RF from that antenna go that far, plugged into the wall of my house with low power.
He still enjoys his childhood hobby, but working foreign countries is easier when your antenna's taller. And bigger boys need bigger toys.
Well, it's a 70-foot steel tower. On top there's an antenna array that's all aluminum that operates in the 10 to 40 meter band. And the antenna array has a motor attached to it so you can rotate the tower to the part of the world that you'd like to communicate to.
Back and forth. And hams in every country send each other cards to commemorate their hookup. Doug's cards cover the wall in the ham shack.
Countries I've talked to as well. I've worked about 200 countries.
Doug has more globe to cover. There are 326 countries with amateur radio call signs.
I guess thank amateur radio for getting me started.
The magic of radio to be able to listen to signals around the world. It's changed a little bit today with internet and whatnot, but as a 15-year-old child and talking around the world in the basement with my little radios and wire antennas was a thrill that will never repeat. You can't sleep at night because you're so excited. The magic of radio.
K0, pop extra clear.
When we come back, Simply Science answers the question, what's the electromagnetic frequency of the television waves you're now watching?
Channel 11, zzz, Channel 11, zzz, Channel 11, zzz.
Television, the next big wave in the evolution of electronic communication. Here in the control room at KARE11, the production crew weaves together the many pictures, sounds, and words that you see each night on the weathercast. Meanwhile, over at the Pavek Museum, the students are finding out what it's like to be on TV, too.
Are we ready, ladies and gentlemen? Okay, here's your first question for 20 points. Name any form of electronic communication. Mac?
Television?
Television, that's a good one. Give them a nice hand.
On the Pavek Museum's quiz show, students review what they've learned about broadcasting and watch themselves on television. Early children's television shows like Howdy Doody and Channel 11's own Lunch with Casey and his sidekick Roundhouse Rodney were broadcast in black and white. In those days, Channel 11 had the call letters WTCN.
And this is the camera that was used to broadcast the Minnesota Twins and, of course, the Millers, the Minneapolis Millers, from 1953 to 1967. It's an old TK-30.
Music, I can wish you merry music while you're young.
At the Pavek Museum, you can see some of the first television sets ever built and portable models from the 1960s. Visitors walk amidst a unique record of radio and television technology. Technology we often take for granted today. The garage door opener is a miniature radio transmitter. It sends a signal to a receiver that turns on a motor to lift the door. A cordless telephone uses a transmitter tuned to a radio frequency too. And so does a remote control for your CD player or your television. All these gadgets, even the television, use waves of energy in the radio band of the electromagnetic spectrum. Further up the scale of frequencies are the microwaves. Harnessed in another household appliance, what else? The microwave has a transmitter inside, like a TV with only one channel. When you turn it on, the transmitter sends a beam of energy tuned to the frequency of, get ready for this, water. The water molecules in the food vibrate. Their friction melts the cheese. This is where all the magic happens. No, this is where Ken Barlow, Mr. Science, and I work. First of all, I have two different radars. I have the radar that's over there, and that is the Nexrad Radar, which comes from the National Weather Service. And it is really, really sensitive. In fact, it's so sensitive, it can pick up a flock of birds flying. It's so sensitive. And this is the one that's actually right on our roof. And this is our Super Doppler 11. And that works pretty much the same way as the Nexrad. Inside a weather shield on the KARE11 roof, our Super Doppler 11 radar scans the skies with a powerful microwave beam. The beam can reach rain or snow falling from clouds as far as 200 miles away. A bit of the beam's energy is reflected back and heard by the receiving dish. These echoes are then plotted on a map. When we're preparing a weathercast, We keep an eye on the radar display and often use a time-lapse replay of radar in the show. That way, we all keep a beam on the rain and snow. When electric weather returns, some of the students from the Pavek Museum join us in the KARE11 studios for a peek behind the scenes of broadcasting the weather.
Hey, Belle, do you remember the first time you stood in front of one of these Chromakey walls?
I sure do. This is one of the classes they do not teach you in meteorology in college. You just have to learn about it, the whole mirror image. I do remember that my knees used to shake and my voice used to get very high because I used to forget to breathe all the time.
I know, it's kind of a stressful thing learning how to look in the mirror, so to speak.
I think we're both a little bit better now.
Hopefully. From television's earliest days, you know, weather has been one of the most important reasons why people watch local news, no matter how primitive the presentation.
As we check the Minnesota map, we'll find out lows tonight will range between 10 and 15 degrees up north, cloudy skies, occasional snow. Here's the radar as it's actually happening at the present time. We can see the shower, a very light one, but nevertheless it is still there right over the areas near St. Cloud. Up north, we have a very strong wind flow coming in off the Gulf of Mexico. That's what's giving us the cloudy skies, but that's also what's giving us the warmer temperatures.
Hey, you ready? Change is a constant in the broadcasting business.
The East Coast is having its share of a variety of weather conditions, all of which are not pleasant.
Once upon a time, weathercasters even presented the weather using little more than fancy chalkboards.
Yesterday, believe it or not. We have a satellite picture here, very interesting. I'm going to put it in.
We still use the satellite replay, which are aerial photos taken every 15 minutes by an infrared camera on a satellite orbiting the Earth. The electromagnetic waves an infrared camera is in tune with have a frequency range higher than microwaves, just below the range of visible light.
As we take a look at the storm system, it's really
We display 30 satellite pictures every second, and this time-lapse turns the cloud movement of a day into just a few seconds.
Now I can render it really fast as a rough cut. Are you rolling? Yep.
Today's computer power lets us combine satellite and radar data. The KARE11 graphics system renders the data into a 3D animation that seems to fly through the atmosphere.
Because it's 9 o'clock now and the show is continuing, and we're just about to do some weather. So we're going to set up the Chromakey. Do you guys know how this works?
Chromakey is one of the oldest electronic tricks in the weathercaster's magic bag.
Do they do that Chromakey bit over in the control room? Or?
The camera has 3 different colors in it, red, green, and blue. And we use one of the colors and take it out and substitute it with the video source.
The source might be the satellite loop or a live radar image.
It's an electronic sandwich with the background and then the Chromakey on top of that.
That's pretty cool, huh? Yeah. See where you are? See if you can do this. Here, I'll move out. You guys see if you can do this. Point to International Falls.
Somewhere over here.
Aberdeen, South Dakota. Where's Aberdeen? There you go. She's got it. In the end, electric weather is really the story of communication, people talking to each other and sharing ideas. And usually the topic that comes to most people's minds
is how's the weather? Thanks to our friends at the Pavek Museum for all their help.
We hope you enjoyed finding out more secrets about electric weather. I'm Belinda Jensen.
And I'm Ken Barlow. Thanks for joining us.
That's the keeper. Nice take, everybody. That's a wrap.
Hey, you know, Ken, what are the chances of getting struck by lightning here in Minnesota?
I think it's 1 in 12,000.
How'd you know that?
Hey, remember that close call I had with the pickup truck?
Oh, that's right.
It's called first-hand experience.
Mm-hmm.
Oh, I felt that one.